guys, welcome to another video for the RC Tractors website, and today we're going to be talking about this motor controller chip. It's a TB6612 FNG. That's the number of the chip, and this is just a little breakout board that I bought the chip on, so that it's a bit easier to solder to, because obviously that surface mount chip, I don't think I'd be able to solder to that. This chip, what I wanted really was a surface mount version of one of these chips. This is an let me just check the number. Yeah, this is an SN754410NE, and that's the motor controller chip that I kind of use in most of the models that I haven't used a servo driver board or something like that in. So this would be in the Scania R620 model, and I was just looking for a surface mount alternative. I found this. It's quite a low profile design, this, but I suppose that will help you when you're looking for space in the model. There's a lot of space under the cab, but it's very low. You don't have a whole lot of room. You'd be able to fit this under the motor in, I'd say, in the Fendt model, whereas you mightn't be able to find the room with this. That said, you have a lot of trouble then getting wires and stuff like that around. Another plus side of this is the way that the pads have been aligned here. So if we look here, we have this is a PWM input here for A. So it's split into two. It will drive two motors. So section A is the first motor, section B is the second motor. So up the top here we have the pulse width modulation for section A. So that's going to determine the speed of a motor connected to A. And then we have A in 2 and A in 1, and they are the direction of the motor. Next pin is a standby pin. So unlike this chip, we can turn this one off into standby mode. Say when the controller is in the neutral position, we can just turn this chip off completely, so that the motor, or so that the tractor isn't jerking back and forward like a problem that you get with the servo driver boards when you're using them. And then further on we have the B input 1, B input 2, and the B pulse width modulation. And all of this is on, all the inputs are on this left hand side, whereas on this chip you had the inputs and the outputs on the same side of this chip. So on the left was for motor A, and on the right was for motor B, and that was a little bit annoying that you had to run the wires across the chip, whereas with this, all the inputs go this direction, all the outputs go this direction. It's very simple. The wires won't be crossing over, and that also means that you don't have wires running over here. So you know, if you have wires running across here, then you're increasing the height of the board again. So with this, we can just simply run the wires out here, and they won't increase the height of the overall chip. So on this side then obviously is the outputs. Up the top we have the voltage for the motor, the voltage for the chip, which is probably either 3.3 volts or 5 volts, and then we have the ground ground, and the output for first motor for A, output 1 and 2, outputs for motor B 1 and 2, and then we have grounds here. So you probably want to put a rather large ground for the motor, so that you know, it can handle the current that you need to drive the motor. Okay, so everything is labelled on the back of the breakout board here. So if you want to recreate this, all you have to do is look on the back of the board and wire it up as I have it here. So what we have is are two wires from our motor here. They are going to A out 1 and A out 2 on this side of the motor. Then up here we have the top pin here is the motor voltage. That's this top pin here. The next pin in is the voltage for the microchip. I have the two of them connected because I'm using 3.7 volts. So 3.7 volt battery, so I'm not worrying about the voltage of the chip. But you should normally regulate VCC to under 5 volts for your motor driver chip. The motor voltage can be more, but the voltage for the chip has to be under 5. You then have, on this side we have the control pins. This top wire here, top one on this side, is the pulse width modulation pin. So you'll normally feed PWM signal on that pin to regulate the speed of the motors. Then you have, let's see, the A-in2. So A-in2 is the next wire down here. I have that connected to the positive. A-in1 then, it's green wire, is connected to the negative. And then the next pin, which is this long one, is the standby pin. So at the minute I haven't got it connected, so it's effectively 0 volts. So the chip is currently in standby mode. So I'll turn it on. So we turn it on and our motor starts to spin clockwise. Okay, so that's with our standby pin. And that's because I have the enable pin, the PWM pin is at 5 volts, so it's high. So I'll switch to green and red wire and we should have the motor going anti-clockwise. So I switch the wires, I'll connect the standby wire to 5 volts again. Now move anti-clockwise. Okay, so anti-clockwise. Something that's usually a big problem with motor driver chips is the voltage drop across the chip. So on the right here we have the battery voltage, so we've about 3.9 volts. And if I connect to the or I connect the standby pin to the 5 volts, turn on the motor driver, and the output is here. So here's the output, 3.88, 3.89 here, 3.9, around about that. So it would appear that there's very little voltage drop in this chip. I was expecting there to be quite a bit of a voltage drop, because I normally have trouble with the L293D chips and the SN74 chips, that when you take these low voltage batteries that you have nearly no voltage on the output of the motor driver. So I'll just check this by connecting it up to the motor and see what the difference is then. Okay, so now we have the motor wired in. We have our 3.9 volts on our battery still on the right. Now we have like 0.2 of a volt difference between our battery and what's being applied to our motor. If we load it down a bit. It seems to be good, consistent. I think the old motors, or the old motor driver chips, weren't this good, so I'm going to get the other motor driver, wire it up in the same configuration, and we'll do this exact same test again and see what the voltage drop is with the old chip. I think this is going to be much better. Okay, I've set this little board here with the two main chips that I was using before. That's the L293D, is the one on the left, and the number of the one on the right is SN75441ONE. and there's one or the other of these in the Fent and in the Massey. So these are the chips I've primarily used up to this point, and I suspect that they're going to perform much worse than the chip we are looking at today, than this new breakout board. I'm convinced that the voltage drop is much more, so now we're going to test it. So at the minute here I'm wired up to the L293D, which I think is the older of the two chips. So if I put the power on, see our battery at 3.6. Oh yeah, look at that, 1.6. We've lost 2 volts. We've lost 2 volts across this chip. Whereas with the new chip that we're looking at, we'd only lost 0.5 volts, something like that. So this chip is 4 times as bad as the new one. Let's check out the other chip here. Basically, I just set these up in exactly the same configuration as what we were looking at earlier. I just didn't leave it so that I could change the direction or anything. I just fixed them in position. So I'll switch the wires over here. So this is the SN75 chip. 3.74 here, 2.1, so 2.2, but 1.5 volts lost on that one. So it looks like, I think this was the older chip, so it performed worse than this slightly newer chip, but they both perform much worse than this new chip that we're looking at today. Now, I had been using these with 7.4 volt batteries, and I had intended to go a 7.4 volt battery into this, but now after seeing how low the voltage drop on this motor driver chip is, I might actually try and use one of these 3.7 volt batteries. So we'll have to have a look at that. So the final test is obviously to check it with an actual Arduino driving it. So I have an Arduino here. It's taken a voltage from this potentiometer. It's reading it on pin A0. So A0 is there. And on pin 2 is one of the directional controls. So A in 2, I think that is, on the motor driver board. Pin 4 is A in 1 on the motor driver board, and PWMA is this white wire. That's going to pin 3, which is a PWM output. So what happens here is it reads the analog voltage, or the analog input reads the voltage from this potentiometer, and then it adjusts the pulse width modulation of that pin 3 output based on the value of the potentiometer. So now we have control of the tractor. That is until we knock the wire out. So these wires are only loosely held in here, that's why they come loose. So if you have voltage, you can get 3.1 volts. .1 volts in reverse. So safe to say, this motor driver is considerably better than the previous motor driver chips that I had been using. So I strongly recommend switching to these new chips. The number of this new chip is TB6612 FNG. And I'll upload the code that I used here to the blog and to the website too. And if you have any questions, post them in the forum, and I'll be very happy to answer them. I hope you found that interesting. Thanks for watching.